Hi, Assalamualaikum and good day to everyone. For the first video, I'm just going to talk about the internet. This is the part one from chapter one. So, these are the outlines for chapter one. However, for today, I'm just going to talk about the introduction to the internet. Okay, so I believe that all of you have known what is the internet because we use this every day. And can you imagine? Just imagine what will be our world without the internet. Okay, so basically, the definition of the internet is actually a computer network that interconnects millions of computing devices throughout the world. So before this, the computing devices are just desktop or personal computers or workstation and servers. But somehow now it has evolved with the billions of things can be connected to the internet. For example, laptops, mobile phones, sensors, and these sensors made up this Internet of Things. So we can say that all aspects of our life now depend heavily on the internet. And all devices that are connected to the internet can be called host or end systems. So after this, when I said host or end systems, so it means that the devices that are connected to the internet. Okay, so let us look at the internet from the hardware or from the fundamental view or nuts and bolts view. Okay, so basically these are the things that made up the internet, okay, which are hosts or the same as end systems. And these end systems are connected together by a network of communication links, okay, using the packet switches. So we are going to learn more about packet switches after this. Okay, so it can be PC, server, wireless laptop, or smartphones. And for these communication links, there are many types of communication links, for example. And these hosts run the network applications. Okay, the network applications, for example, all these applications on your mobile phones or um, whatever web page that you want to connect. Okay, and so back to communication links, it can be fiber, copper, or radio satellite, and it depends on the these communication links can have different data rates, okay, which is measured in bits per second. So when one end system wants to send a packet or a data to another end system, for example here, okay, the sending end system here will send data segment by segment. Okay, so we are going to learn more about this in the next chapter. So each segment will have a different header, okay, to be added, which this header will have the destination address, for example, the sender address, and many other information. So we can also say that this packet is we can also call this segment as packets. Okay, so these packets are sent through this computer network, okay, to the destination and system, and at this destination here it will be reassembled into the original data. So again, this is actually part of packet switches. Okay, so packet switches forward packets or chunks of data through these routers and switches. So what is the routers? These are the routers. Okay, if you see this as or also we call it switches. Okay, so these routers and switches, the task of these devices is to route the packets towards the destination. Okay, because in this example, it's just a small network. So imagine that we have billions of connected devices right now. So can you imagine if you want to send data to someone or a device which is far away? For example, I want to send data to you in Iraq. So can you just imagine how that data is route towards the destination? So it involves many routers and switches with high data rate as well. Okay. Okay. So more on the internet in terms of the hardware and software view. So internet is also called networks of networks, okay, in which is made out of the interconnected ISP. ISP is the internet service provider. So end system or our devices connected to the internet through this ISP, okay, or internet service provider. So this ISP include residential ISP such as local cable or telephone companies, or for example, at my home my house is connected to the internet through Unifi, or university ISPs, internet service provider, for example, in UTM, or any ISPs that provide Wi-Fi access, for example, airports, at the coffee shops, or any public places. Okay, so each ISP itself is a network of packet switches. Okay, if you can see here, there are many switches and routers, and also communication links. Okay, this is an example of institutional network. Okay, regional ISP, global ISP, and so on. So these ISPs provide a variety of types of network access to the end system. So including the residential broadband access. Okay, it means that we can connect it to the internet. We can connect it to the internet through the fiber optic, or through, or perhaps some of the places still use the traditional cable modem, okay, or perhaps use the DSL or local area network access. Okay, so there are many types of access. Sorry. Okay, and then if you notice that these ISPs also have to be interconnected within each other. Okay, for example, at the home network, okay, the ISP is connected through a national or regional ISP, and through the international or global ISP. Okay, and institutional network also connected to regional ISP. Okay, so an upper tier ISP or global ISP consists of many high-speed routers interconnected with fiber optic communication links. Okay, so each ISP network, whether upper tier here or lower tier, is managed independently and runs the internet protocol. Okay, internet protocol to control sending and receiving of the message. So this IP protocol conforms or follow certain naming and also address conventions, okay, in which we will learn in, I think, in chapter 4. Okay, and each end system here, packet switches or other pieces of the internet here, run many types of protocols. Okay, so basically in our course here, we will learn so many different protocols. Okay, there are many different protocols, for example, to send message or to receive message, or in case there are errors, or to request for the address, and many more. Okay, some of the protocols is called these are some of the examples of the protocols. TCP/IP, HTTP, for example, to connect to the web page, Skype to communicate, and 2.11 for local area network access. Okay. All right. So we are going to learn more about TCP/IP in the second chapter, I think. Okay. So basically, these TCP/IP protocols is the most important protocols in the internet, and the internet IP or internet protocols here also one of the most important, because it specifies the format of the packets. Okay, so when you send data, you cannot just you have to imagine that all these data have the specific format of the packets. Okay, it must have the destination address, might have the size of bytes, for example, the type of the information, and also the sender address. Okay, just imagine if you want to send a letter to someone. Okay, and when you write an address, it must have a specific format. So it's the same as data as well. Okay, so given the importance of protocols to the internet, it is important that every users of the internet here agree on what each and every protocol does. Okay, so that this system can be interoperate even though the management of the ISP is independent. Okay, so this is where internet standards come into play here. Okay, because we need to have a standard. Okay, again, we need to have a standard so that all devices that are connected to internet are compatible to use the internet technology, okay, the current internet technology, and many other services offered by internet. Okay, um the internet standards are developed by the IETF, okay, Internet Engineering Task Force. So all the documents by IETF are called RFC, or request for comments. So you can just Google RFC. So there are many standards by IETF. So uh, perhaps in the next few chapters, we're gonna see also different RFC for different standards. Okay, this RFC actually started out as general request for comments. That's why the name is RFC, to resolve network and protocol design problems that face the precursor to the internet. Okay, so basically, developers will use the RFC to develop new, as a reference to develop new apps or to solve any problems related to the internet. Right. So, if we look at the internet from a service view, okay, it is actually infrastructure that provides services to applications. Okay, so the application, for example, the web page, sorry about that, the voice over internet protocol, the email, the electronic games, e-commerce application, shopping online, and so on, and the most popular one is social network. Okay, so these end systems on all our devices attached to the internet, okay, provide an application programming interface. Okay, programming interface to application. So this application programming interface, or we call it API, specifies how a program run on one end system can ask the internet infrastructure to deliver data to the internet, to deliver data to a specific destination program running on another end system, for example. So in short, this API, this application programming interface are hooks that allow sending and receiving application programs to connect to the internet. Okay, and it provides service options that is analogous to postal services. Okay, for example, if you want to send a parcel, okay, to anyone, just an example, from Malaysia to Iraq using the postal service. So, of course, we can't just drop that parcel out of our window, right? So we need to have proper convention to follow. So in order to post that parcel, we need to have the cover, or for example the envelope you want to send a small parcel, and we need to have the um, for example, if you want to send to Ali, for example, okay, we need to have Ali's full name, address, and zip code, okay, on the envelope or on the parcel, and we have to seal properly or wrap properly the parcel. In this case, we need to have we need to go to the courier service, okay, pay the for the courier service, or if just a small parcel, if we just want to use the postage, the normal postage, we have to put the stamp, okay, and we have to drop that envelope into the official courier service mailbox, or just give to the courier service. And this courier service or postal service has its own API, okay, application programming interface, okay, example, or set of rules that this company have to follow. Okay, so I repeat, this postal service or courier service has their own set of rules that they have to follow in order to deliver the parcel to Ali. So in a similar manner, the internet also has an application programming interface that the program sending data must follow to have the internet deliver the data to the program that will receive the data. Okay, and the postal service, of course, provides more than one services to its customers. Okay, there are so many, for example, services such as express delivery, or if you want a reception confirmation. This is an example of the postal service. Okay, if the normal postal service, if you want to put stamp, we can request express delivery, so perhaps we have to pay more, or reception confirmation, meaning that the um, the receiver must sign upon receive the parcel, or upon receiving the letters. Okay, or just ordinary use, or many more services. So in a similar manner, also the internet also have many services uh, that can be offered to its applications or users. Okay, so moving on. The next one, like I said before, we have so many protocols. Okay, we are going to learn also so many protocols, but you need to know what is the definition of protocol. Okay, let's say a normal person, if you want to ask what is the time now to anyone that we do not know. Okay, so the first or the proper manner that we want to use is we say hi or assalamualaikum to initiate communication with anyone else. Okay, anyone that we don't know. Okay, and the typical response is probably hi or waalaikum salam. These are the response which indicate that the people that we want to ask question for can proceed, or we can proceed to ask any question that we want to ask them. Okay, uh, if the person that we say assalamualaikum to or hi to responds with hi as well, so we can proceed to the next question, which is do you know what is the time now? Got the time now? And he or she will reply, oh, it's 2 o'clock in the afternoon. Okay, so this is actually the protocol that a human will use to communicate with each other. However, for example, if you would say assalamualaikum to anyone, but that person did not answer, or that person will probably answer, hey, don't bother me, or don't disturb me, sorry, I don't speak English, or I don't know you, or maybe any response that indicate that they are not willing, or they are not able to communicate with us. So perhaps the normal response from us is just quiet, or we have to ask another person. Okay, so this is basically a human protocol. So this is the same as the internet protocol. Okay, for example, when a device wants to for example, in this network protocol, for example, a device wants to communicate with other device. Okay, so or to request information from the servers, so this device will send the TCP connection request. Okay, and the server will respond with TCP connection response. So this is only an example. Okay, we will learn the details in the next chapter. And then the device will put on the address. For example, this is the address of the website that it wants to go, and the server will reply with the file for that, or with the web page that we want, that this device want to access to. So basically, um, we can see that it is analogous to human protocol. Okay, as well. So except that the entities exchanging message and taking actions are actually hardware or software component of some devices, and all the activities in the internet that involves two or more communicating remote entities is governed or managed by a protocol. Okay, so this is what you have to understand. Okay, so this is to repeat the previous slide. Okay, for the network protocols, the protocols involve machines rather than humans. Okay, so these are the humans protocol. If you want to have question, or we want to ask the time, we need to follow like a proper sentences, which is a proper in a proper manner way. Okay, for network protocols, all communication activities in the internet are governed by the protocols. So basically, the protocol define format, order of messages sent and received among network entities, and also actions taken on message transmission and also receive. Okay, so in order for a message to be sent and also received among the network entities means among the devices or among the servers or among the routers or switches, there are protocols that need to be followed. Okay, there are format that need to be followed. Okay, the order of the message also plays an important role, and so on. Okay, if we have a closer look at the network structure, okay, we have a network edge. Network edge is also called host, okay, host or end system. So we refer this as end system because they sit on the edge of the network. Okay, this is what we call network edge. Okay, at the end of the system. Okay, so this is the host. It can be clients and also servers. Servers often reside in data centers, for example, Google, and we have this client and servers, and clients normally tend to be this desktop or mobile computer or laptop and so on, and or smartphones, and servers tend to be these more powerful machines which store and also distribute web pages and relay the email and so on. Okay, and they also host application programs such as web browser program, email client program, and so on. So these servers, like I said before, it reside in the data centers. For example, Google, they have thousands of servers. Okay, and this access network is the network that physically connects an end system to the first router. Okay, um, this is also known as edge router. For example, from this one end system to another distant end system. Okay, so this is the access network. Okay, that connect to the router. Okay, it can be wired or wireless communication links. Between source and destination, like I said before, the packets travel through packet switches, which we will learn in details later. Okay, and at the network core here, we have the interconnected routers. It has to be interconnected or otherwise we cannot send or receive message. Okay, and this is called also network of networks. Okay, and these are the trend of contemporary data communications. If you see at the trends here, traffic grows at a high and steady rate. Always there is a new services every day developed by developers and offered on the market. So we can see that the technology of the internet grows rapidly, and with the advances in technology we have so many new technology. So this will be your next assignment, and I will put the next assignment on the e-learning. And because of these advances in technology, there are also significant changes in requirements. So this explains why so many researchers are still working on the network, because it is a technology that basically evolve every day. So I think every like 2 or 3 months we will learn or we'll hear a new technology being developed. So it's actually a bit hard to keep up with the new technology, but you know, we have to keep up. Being a telecommunication, one of the telecommunication engineers, we have to keep up with the technology. At least we need to know the name of the technology. So with the emergence of high-speed local area networks, 4G networks, 5G and 6G, so there are many significant changes in the requirements in terms of hardware or the networking or the software. So for example, for the hardware, the antenna involved for the 4G networks and 5G networks are totally different. The requirement in the network, okay, and the corporate wireless area network is needed as well. And also in the requirements of digital electronics and also portable devices are also changing with the advances of technology. Okay, so these are all ongoing research, so it opens many opportunity for research, for PhD research, and for R&D research in the company. Okay, right. I think for the first part of this chapter, that's all for today. So I'm going to explain another part, perhaps face to face via WebEx, okay, in the next lecture. Okay, so thank you very much for listening.